Hi there, myself Madhav Jha. I welcome you to CodeChef and let's have a look at this question.
The problem is near yet far. The problem difficulty is easy and there are no prerequisites. Let's have a read at the problem. You are given an array A of length n as well as an integer k. Now we need to find a sequence of indices a1, a2 till ar, and we will tell that it is that it is valid if it follows certain rules. The first rule is that all the indices are in increasing order. Next up, the indices that we have chosen are not adjacent to each other. So simply what we want to do is with k is we want to segment our array into k subarrays, and then we'll have to choose indices among them, and we have to make sure that the indices that we have chosen are not adjacent, but we also need to make sure that we choose at least one index from each of these segment, and the length of the segment is k. Now we need to find out whether it is possible, and if it is possible, then we need to find out the maximum minus the minimum among the elements that these indices represent. I need to find, I need to maximize this equation. So let's see the input format. We have t test cases, and for each test case we'll have two lines. The first line will contain two integers n and k, and the second line will contain n spaced integers that will be a1, a2 till an. As for the output, we just have to output the maximum possible value of the score. As for the constraints, number of test cases will go from 1 to 10 raised to 5. Length of the array will go from 2 to 2 into 10 raised to 5, and value of k will go from 2 to n. As for the values of element itself, it will go from 1 to 10 raised to 9. Let's see the sample inputs. So for the very first sample input, we only have two elements. Now, if we have to choose two indices, we can't do so because that will be adjacent and we don't have any other option. Therefore, the answer is 0. Now, as for the second example, what we have with us is four elements 8, 1, 4, 3, and k here is of size 3. So we have to make segments of 3. But here we can't make the second segment of size 3, but that is fine with us. Now what we'll do is we'll now choose again. Let's say the first index that we have chosen is 8 and the second that we have chosen is 3. Now in this, the maximum is 8 and the minimum is 3 and the difference is 5. And this is the maximum that we are going to get. Next up we have 2 as our k value. The array has 5 elements and the elements are 5, 12, 5, 9 and 8. Now if I choose this index, it is impossible to choose the second index because this will be adjacent. So we can either choose all the odd elements or we can choose all the even elements, right? So in this case, if we choose all the odd elements, so we will have 12 and 19, right? Let's add the indices so that it is easier. So if we choose the odd indices, we have 12 and 9. The max is 12, the minimum is 9. So the difference is 3. What would happen if we choose all evens? Again, the maximum is 8, the minimum is 5. Again, the answer is 3. So this is the maximum that we can get. So let's see how we can approach the solution. So the base case that we can think of is when k is equal to 2. Now if this is the case, as we have seen, we are forced to choose either all the odd indices or all the even indices. So we can simply do a maximum of this. We'll take the max value in all the odd indices and subtract it with the minimum. We will do the same for even, right? We'll take the max, subtract it with the minimum, and then check which is the max of this. Whichever is the maximum, that will be our answer. Now what happens if k is greater than 2? Now it opens us and gives us more wiggle room to decide what are the elements that we choose to have and what is the score that we can maximize. Now first imagine what is the maximum answer that we can get. Is it not the total maximum of array minus the total minimum? If we do this, this is the maximum answer that we can get. This is the best that we can get. But can we achieve this? So to do so, let's see what we can do. Once we have our array, we need to make sure that while we are choosing the indices in this segment of k's, we need to make sure that the maximum that we have chosen, let's say it lies somewhere here, and the minimum that we have chosen, it can lie anywhere that we want, right? Anywhere that it is, just need to make sure that it is not adjacent. Now, the only case where we can't avoid this, if it is already just adjacent, right? If this is the case, there is nothing that we can do. But what is the next best thing that we can do? Now, since we have more wiggle room, what we can try to do is we can just try to see what is the maximum that we have with us. And then if we just leave the one element that avoids it being the adjacent, can we get the minimum there? If we can do so, for the rest of the elements, we can try to shift a little bit them here and there and make sure that they are not adjacent. The only values of our concern are the maximum and minimum. So for this, what we can do is, let's say we'll start our maximum and minimum with the first element. And then we check the third element, not the second one, right? We have chosen the first, we have chosen the third, but not the second one. Now, once we have this, we know that we will keep a prefix sum of minimum and maximum, right? We are coming from left. Currently, we have only seen the first element. Second, we are not seeing. And third, we are trying to explore. Now, what can happen? Now, there's a chance that third element is either a maximum or is either a minimum. Whatever suits our taste, right? If it is maximum, we'll try to see what is the answer that we get after subtracting minimum from it. If it is minimum, then we'll check what is the value if we subtract it from maximum. Whatever is the result, we keep track of it. Now, move ahead to the fourth index. Now, as we do, we will now take into account the second element that we left previously. We will check and compare it with the minimum and maximum and reassign them. Now again, we will have a minimum and maximum with prefix of these two elements. But the third element is now skipped, right? We are not checking this. This is not included in our minimum or maximum, and we are not comparing it. So we are comparing the elements 1, 2 with minimum and maximum along with 4, checking whether it is maximum or a minimum or whatever fits here. And whatever it does, we try to calculate the maximum result. So in this manner, what we'll try to do is we'll try to check whether it is possible to get a maximum and minimum. Once we get this, the others can easily be arranged. And in this scenario, we are not concerned about writing out or giving the output of all the indices. We just want the score. So this solution suits us. We'll simply calculate it and find out what is the maximum, and that will give us a solution. Let's see how we can implement the solution in C++. So for each test case, we call the function solve. In solve, we take the input of n, k, and then we take input of odd and even. We take the input of array. And with this, we create our odd and even arrays. Now, if k is 2, we simply check the maximum and minimum, both for odd and even, and whichever is the maximum gives us the maximum score, we print that. But if that is not the case, then we go over and check what is the next best that we can get when our k is greater than 2. In this scenario, we keep the min as prefix min and max as the prefix max. This stores the first element, and we start with the third element because this is 0 key based. Then when we are checking whichever element that we are going over, we simply check what is the score that we can get with this. So with maximum, we subtract it. With minimum, we subtract minimum from it, and we compare what is the max score that we can get out of this. Then once we have done this, we include the previous element. In this case, that would be the second element to our minimum and our maximum. We keep on doing so and find out what is the maximum score. Whatever it is, we print them, and as you can see, I have AC in Python implementation. Let's see how we do this in Python. Again, for each test case, we call the function solve and take the input of n, k in our array. Then if our k is 2, then we find out our odd indices and the even indices. Among them, we find out what is the maximum score. Score being nothing but the maximum element minus the minimum element. We find out what is the max score and print it. If our k is greater than 2, then we do this on a rolling basis. We have our prefix min and prefix max. We go over it and check each of the element as we have seen in the approach. At the end, whatever is the max score, we print it, and as you can see, I have AC in Python implementation as well. So I hope you understood the problem, the approach, and how we can implement the solution in both C++ and Python. Have a very good day, and I'll see you in the next video.